Good morning. Good morning, guys. Nice to see almost all of you here. Yesterday we were looking at some of the fundamental principles of geology. So geology is study of the earth, how the earth probably formed, what are the components that make up the earth, and also we see that the most of the disasters have a component of geology associated with it. What do we mean? We see that all the human activity is on the surface of the earth, and this is what is getting disrupted. So we are studying the surface of the earth. Yesterday we saw that there are different kinds of landforms which are being formed. We also saw the agents of weathering. It means that this sun, the wind, that's air in motion, water which is in motion, water which freezes, water which thaws, all of these when they act in a cyclic manner, they form the products of weathering. The products of weathering is soil. Again, we saw that soil can, because of the components of the soil differs. Soil can be made of organic or inorganic materials. So combined together is soil. So the organic component of the soil makes the soil fertile. In other words, lets life be sustained. And the other thing is the nature of soil is dependent on the constituent elements. In other words, how much solid material is there, how much water is there, and how much air is there as a fraction. So how much of air is there as a fraction, all of these determine the strength. So we saw that on the beach we have had an experience. The foot, which is like the foundation, rests on soil, and when the soil gets wet, we feel that our foot goes down. In other words, when the constituent of the soil changed, there was a certain amount of air, there was a certain amount of water, there was a certain amount of solid material. When this changed, you found that you lost strength. Okay, now this is going to be the basis of some of the concepts which we are going to observe. We will extend these concepts to see how we can prevent what we call as the prevent large scale damage. In other words, this will become the mitigating factors. Okay, and we also saw that the earthquake, the tsunami, and landslides, these three are interdependent. There is a relationship between them, and we will try to see what it is so that we can understand some mitigating aspects. Okay, now it's very easy to visualize a person standing on the beach. Now we will have if you go through one of the concepts which we spoke about was liquefaction. Now liquefaction occurs when water in the soil is excited. So when water is excited, it starts to move around. It starts to move between the pores, and then it reaches the top part of the it just moves around, and then it disturbs the entire mass of soil. In the process, it also causes it to lose what is called as the shear strength. Okay, now I don't know if you remember what is shear strength. Shear strength is nothing but resistance to sliding. So suppose you look at if I am going to drag this box horizontally with the force F, this is being countered by friction over here and the friction which is generated over here. So friction gets generated in the interface between the surfaces. Okay, now if suppose I am going to push, it is called compression. Again, if I am going to pull, this is called tension. If I am going to slide, it is called shear. Okay, now one of my favorite definitions for what we call as fluids was taken from a book by V.L. Streeter, in which fluid is defined as a material that cannot take shear stress. Okay, fluid is a material that cannot take shear stress, and because of this it flows. Because of this it flows. So essentially, if you see honey, the layer slides and falls, the next layer slides and falls over it, then so on and so forth. This keeps on going. Now if you look at sand or soil, soil sometimes behaves like a fluid. Okay, so suppose you take soil in a beaker. Okay, you take the soil in a beaker and then you pour the soil. So when you pour the soil starts to slide. The soil starts to slide, and when it falls also, it takes a particular shape. It takes a particular shape. This shape is almost invariant under certain conditions. The constituents of the soil makes it up. So usually how dry it is means presence or absence of water, how much water is there in it. And again, there is one more very important what you call as a material property. It is called a internal friction. Okay, so now what happens, if suppose you look at this, essentially the soil keeps sliding. The soil keeps sliding. In other words, it is continuously undergoing a shear stress. Okay, but at one point it reaches equilibrium. At one point it reaches equilibrium because it is able to resist the shear stress. Now, what is the way by which this material is going to resist shear stress? Let us see how grains are going to look like. The grains are all not going to be regular. So you will find that when it is very granular, when the grains are going to have granular means, it's essentially in a grain form. So you will find that there is an interlock. So you can take this example, go home, go to your kitchen, take sugar and try this. Okay, take it, pour the sugar in a plate, you will find that it rests at a particular angle. You will also find that all the particles of sugar are almost like a cube. Okay, this is when it's highly refined and other things. So what happens is it kind of takes a particular shape. However, suppose there are many sharp edges, what essentially happens, you'll find that it is able to go and interlock with each other. This interlock prevents it from sliding freely. This ability to interlock prevents it from sliding freely. So depending on what is the material, what is the shape, what is the size, you'll find that there is internal friction. Now let me take one more, let me go a little further. Suppose I am having very large particles, I am having small particles, and so there's just 1 minute, I have something. Yeah. So now what happens is we got lots of different sizes. We have lots of different sizes. Now this means when there is a large particle and there is a small particle, you will find that it is able to, the smaller particles are able to go into the wedge themselves between the larger particles. So automatically what happens, the internal friction or ability to take up shear. Okay, just look at this. If the friction, if the ability to develop friction between these two plates increases, automatically the amount of force required is more. Okay, so now this is what actually happens. Now if you go and look at the video which follows, the formal video which I got, which follows this introductory lecture, you will find that there is a soil mass, and then how it is going to slip and fail. You will be having a introduction, and probably there are some landslide videos also which have been given. So this should tell you how the type of soil is going to determine what we call as the ability to take up shear. Moving on, if suppose we want the soil to be able to take higher shear stress, there's one conclusion we can come. So there should be enough ways by which there is a assortment of particles. Usually if there are only large particles, you will find that it will look something like this, and the ability, so if suppose I'm just drawing a little hypothetical one because I'm trying to get a failure plane, you will find that most of these material which is above this line is likely to slip and fail. Yes, please.
Are you sharing your screen, sir?
Oh my goodness, I'm okay guys, if suppose something like this happens, it's so embarrassing. Yes, I have not been sharing my screen unfortunately, and I didn't realize it. Immediately just please tell me, because for some reason we presume that the screen is being shared. Okay guys, I'm very sorry, but I think probably I'll just very quickly have a quick recap of what I've been telling. So this is the plates which I spoke about. These plates are being subjected to a force which is parallel to the plane. So if you see, these two forces are perpendicular to the slipping plane. Okay, so this is compression, this is called tension, and definitely this three plates will take compression but no tension. But definitely when it comes to shear, it depends on the friction force which is developed between these two plates. Okay, so we are just looking at fluids which like gases and liquids. Fluids don't take shear stress, so that's why you see honey slip layer over layer. The other thing is, we are having so if suppose you take this is the beaker which I was talking about. So when you pour it out, it falls out and then it takes a specific shape. Okay, and this slope depends on the friction which is able to be generated, because friction is what is going to prevent you from sliding. So when you are having many fractions, you will typically find that the larger blocks are the space between the larger blocks are filled with smaller blocks, and you are able to get a particular slope. So you will be able to see this better, I mean like probably understand better in the video that follows this lecture. Moving on, so when you are keeping the rocks above a particular point, you will find that it will automatically slip and fall. Okay, so now if suppose all the particles are the same size, that means you will call it as uniformly graded. The other thing is, when the soils have sufficient what you call as fractions or sizes of different levels, then you call it as well graded. Now I am not going into the exact definitions of what range or what percentage of different fractions should be there to call a soil as well graded, but for understanding, there are two types, well graded and uniformly graded. So we will prefer to have well graded soil rather than uniformly graded, which is nothing but soil which is of same size. The other important thing is to any questions till now, please? I'm sorry, any questions till this point? Right, so let's move on. When we are having what you call as a well graded soil, you will also see that suppose I am going to shake it a little bit, you are going to have the space between each of the bigger particles filled with the smaller particles. So essentially what is it that we are trying to do? If suppose you take sugar in a measuring cup or whatever, you will find that it typically takes a slightly heaped shape. It takes a slightly heaped shape. Now you shake it. Usually what you do, you give a shearing force. Okay, you shake it side to side, and the sugar will settle down. It will probably come to something like this. What has happened? All the gaps which were initially there when it was loosely packed have been more densely packed. So now what happens, you will find that when it was loosely packed, you could very easily insert a spoon or something into the sugar. On the other hand, when it's tightly packed, the spoon might not go to the same depth. So this is an important principle to tell how much, like a soil is likely to be able to take some load. Now let us take the same example, let us say that you have taken sugar and heaped it up, and then you keep this empty measuring jar on top of this. Immediately you will see that the shape of this slope changes. So it takes a slightly different position. Now this is the principle which we have for all the slope stability problems. Okay, for all the slope stability problems, these are some of the very basic and very important principles. So if you look at it, when you want to have a slope and you look at slope stability, point number 1, you will be seeing what is the angle itself, what is the angle at which the slope is. Second, and this is a property of the soil which we call as internal friction. So once you know what are the components of soil, you will be able to say what is the likely angle of internal friction. You can do it also from laboratory experiments, and you will say that so this is how this soil is likely to be held up. The other thing is moisture. Okay, there is a third important thing. The third thing is the overburden. Now coming back here, this cup formed the overburden. The sugar which is here had a property called internal friction. Okay, now of course let us say that it was atta instead of sugar. You can add water and then see how it stands, because if you pour water into sugar, it's going to dissolve. Again, that was because of a material property. So again, like I'm sure you will be able to see what happens when atta is having the water mixed. Different amounts of water gives different what we call as properties. Okay, so this is again something which I'm sure you are able to relate. So here we are seeing internal friction, moisture and overburden, the three important things which determine whether a slope is going to be stable or not. Okay, moving on, let us have a look at this. Let us have a look at a mountain, a hill resort. Okay, so you are having a hill resort and you are also having some need. So if you are going to a hill resort, first thing you want is a road. Now I need to cut a road, so I need to make a cut like this. So this portion is going to get removed. So this portion is going to get removed. Oops. Let's see which eraser, small eraser. Okay, now this part is going to get removed, and then you are going to have a bus going over here, bus, train, you name it. Now what has happened, there is a discontinuity. The soil is likely to slip and fall. So what do? We try to keep some kind of slope protection work. We keep some slope protection work. So it can be a retaining wall, it can be a gabion wall, okay, and it can be so many other things. I am not going to go into all of them, but then there can also be what is called as a RE wall or a reinforced earth wall. Typically when you go to any of the flyovers, you see this RE walls, which are nothing but panels. There's a procedure for doing it, but end of the day, whatever is the soil that's filled in, it doesn't flow out. So retaining works have to be done. So if this retaining work is strong enough, you will not have any issue. However, if the retaining wall is not strong enough, you will find that there is going to be huge distress. Then only you have the what you call as the soil overturning and whatever undesirable things which you think about, all of them happen. So typically what happens, you don't have the road only here, you will find that there's the road also coming somewhere at a slightly higher position. Same road has gone to the higher level. So when that happens, what would be the problem? Now this bus starts to become a overburden. This becomes a overburden. So when we are looking at the slope, if I don't want this slope to slip, I have to make sure that this is strong enough to take the overburden. Now this is the way by which we mitigate the chance of a landslide. Most of the times landslides occur because we don't take some of these precautions. I am only looking at the things where human intervention is happening. It need not only be a road, it can also be a house, it can be a hill resort, okay, it can be some other person's house. So all of these are likely to be in danger if suppose we are not taking proper precautions. So typically when you are constructing the house, you might find that everything is fine. However, when there is rain, you will find that there is a change in moisture content. Okay, there's a change in moisture content. Immediately there is going to be this land is going to be slipping. Second thing, suppose there is a disturbance like an earthquake. It need not always be only an earthquake. It can be vibration. It can be so many other things. Immediately you will find that there is a change in density. Okay, again because of this, water can move in any direction. So that again causes a loss in strength of the soil. So when any of these things happen, you are likely to feel that there's going to be issue, right? What is the issue? The issue is that the soil is going to lose its shear strength. Okay, when that happens, the soil starts to flow. Okay, coming back to the definition of what V.L. Streeter said, a fluid is a material that cannot resist shear strength. So water or any other liquid typically is, like all fluids don't have shear, lack the ability to counter shear. So here also what happens, the soil starts to lose its shear strength and then it starts to flow. So if it gains strength, there is no problem. We are looking at a natural disaster. Natural disasters are only going to happen when the fluid is going to lose its shear strength. Okay. Now very quickly, I am just going back to probably a few of the things which we saw. If you have any questions, please ask me. Okay. So we saw about shear strength. We saw fluids as what a fluid is. We saw the relationship between fluid and solid. We saw some of the properties of soil, which is important to understand why soil is going to behave like a fluid and flow. And moving on, we saw we revisited it with an example, the example of sugar standing up, and so on and so forth. We also saw how overburden takes place in soil, and when overburden comes, definitely the chance of slipping is greatly increased. Again, we saw that rain and earthquake also are going to be very important parameters which are going to change the stability of slope. Any questions?
No, sir.
Okay. Moving on, we will see a few more things. One of the very important thing is how can I predict a landslide? So we see that if I know the slope, if I know the soil, if I know the moisture, we can say that a soil is going to be stable or unstable. So this is when there is no disturbance. If suppose there is human activity, you can say that there is one more thing, whether there is overburden. Now there can be a certain amount of overburden, but to what extent? This is something which we are all really looking forward to answering. So if you are able to answer these questions, we can tell whether a soil is going to be safe or not, or in other words, whether a slope is going to be stable or not. So otherwise, what is the engineering intervention which is required? Now today we have some very good tools. What are the tools we have? We have satellite imagery, and we have what is called as the uh, what I should say as machine learning. We have what is called as artificial intelligence, and all of this is not new. So to interpret a data which is there, you can very easily use any of these things. So we can very easily find out what is the slope of soil. So we know the height of a mass. We can also see some of the other parameters. So directly we can find out the slope either from the imagery. Now if you are asking whether it is possible, I'll simply tell you that it is very easy. If you go through one of my videos on which I had given on how to find the slope of VAT lake. Okay, it was done around in the year 2015. We have shown how we can find out the what you call as the profile of the lake. Okay, so profile of the bottom of the lake. Just a minute, let me just get it. So now this is the link, and if you are interested, you can probably have a look at it to see how satellite imagery has really grown. So if you go to this link, you will be able to see the slope of the lake itself. So you can very well imagine how much you can get from the other things. When I was working in L&T, we went to a very remote forest, and then we had to do some survey, and what probably people would have taken 3 or 4 months to do, we were supposed to do in less than 2 or 3 hours. And at that time I used satellite or GPS techniques and superimposing it on satellite imagery to get a lot of information. So if you look at it, to find the slope of a mountain is today very, very simple. So if you don't know, and if you are a person interested in machine learning and stuff like that, here is an opportunity for you to learn. Probably you can do and get algorithms which are better than what Google uses. And believe me, we had a drawing which had been prepared by a professional surveyor. Both of them matched. Okay, so you don't need to really worry much, because your slope getting slightly off by a few degrees is not going to make too much of a difference. So you can very easily find slope. Now yesterday when we were looking at geology, we saw that the type of soil will be having, each soil has unique color. So once you know what is the color, you can very easily say what is the soil which is there. Again, you will find that we have techniques to take imagery which helps us to interpret moisture. Okay. Now if you see Google Earth or Google any of the satellite images, you will be able to make out whether buildings are there, whether a road is there, so on and so forth. You can also immediately say determine the overburden, and moisture is a dynamic parameter, right? So if you see your satellite images keep on changing, so all the technology is in your hands. How we are going to use this is entirely in our own hands. We can probably create models of the earth which tell us where landslides are more likely to happen. So much of research has now come or gone through, we have gone through a lot of research in many of these areas. So with all of this in our hands, I am sure that this should excite our imagination on the possibility of what you guys can probably achieve. Okay, so with this introductory note, I leave it for now. I request you to please go through the what you call as the work which we had done a little earlier, the link which I had shared with you yesterday. Okay, and I request you to please have a look at the stuff which has been shared in that particular link. This is so that just a minute. Yeah, so this is the link which we have. Let's see what happens when I paste it. Yes. So let me again make this a little big, and this link is a video to some of the, I mean, like, explaining the stuff which we have just now spoken about, and I hope that you find that more meaningful in light of what we have seen just now. Okay, right. Any questions from you, please? No?
No, sir.
Okay, bye for now.